Power to the truth. This is Margo. This is Saturday, November 3rd, 2018. And today we're going to do another Arctic sea ice update to see how the ice is refreezing up in the Arctic. And we're going to look at the ice in the Antarctic and some things going on down there. I'm going to bring you a couple of articles, and then we're going to look at some greenhouse gas levels on cams. So what I have here is, this is from Climate Reanalyzer with their snow and ice cover from today, Saturday, November 3rd, and we can see that it is starting to refreeze somewhat up here, but when you see the concentration, you're going to see that it's not real solid. And Paul Beckwith put out a video recently about the refreezing of the Arctic and saying that it's not healthy ice. I'm not sure how he said it, but it's not a good refreeze because the water is so warm and coming up underneath, and it's so warm, and so it's hard to get a good freeze. And he's saying that a lot of it is really mushy. So let's just backtrack like what I like to do to see where we were from our last update. And our last update was on the 19th of October. So I'm just going to start clicking backwards. I've been saving these pictures every day from Climate Reanalyzer so that I can have my own slideshow of whatever day I want to look at. So it was late getting started back, and we're also going to do a comparison from the previous years as to where we are now. So here it was on October the 19th, and you can see that it had not come up to the coast up here on Canada or Alaska or on Russia or Siberia. So it mainly started thickening up, and then it started gradually growing back out. But there is an area that is what you're going to see when we look at Climate Reanalyzer today. There is an area here that is warmer than normal, and that's one reason it's not refreezing as we would like it to. And so we're going to be looking at that too. So here you can see, and here we are from today. And here I've downloaded the Navy animated GIF for a 30-day period, which goes back 3 weeks and goes forward a week. And so we can see, even though the extent is coming out, it's still very thin. It's quite thin, and we're not seeing any really good thick ice forming. What we can see is a little bit of yellow and red forming right down here on the top part of this Canadian island group here. But so it might thicken up as the weeks go by and as the sun goes down up there. So there's that. And here it is from today. This is from the U.S. Navy military website that I like to use. And this is an animated movie that I created from NASA Worldview for the last month of the ice when it goes through today. there, and then it starts over from October the 3rd. And so this includes concentration, not just extent. And the white means more concentrated, and also not necessarily thicker, but concentrated means it's more packed together. And so where it's the blue and the darker blue, it's less concentrated. Like we were seeing the purple and the lavender on the Navy website. So those are my animated GIFs that I prepared for you today. So I'm just going to stop that. And now, actually I'm going to close that. So let's go over to Climate Reanalyzer. I have it up here. Here's our maximum temperatures for today around the world. We can see that it's still quite warm in a lot of the world, and but it is cooling down in the Arctic, which we expect since it is going into winter time there. And Africa is still quite hot. Saudi Arabia, India, the southern Asian countries, there's Indonesia, Australia is having a heat wave, and they're heading into their spring. And South America is quite hot. Of course, the equator runs right about through here. So in the southern part, they're heading into their spring as well. Here's the South Pole, and here's Australia, where it's quite hot. They've had some really hot temperatures already at 40 degrees C. So it's not going to be pretty down there. Here's our 2-meter temperature anomaly map, and we can see in the Arctic, in this red zone, I was showing you that's where the ice has been having a hard time coming back up to the coast of Siberia. And it's also warmer down here above Canada, and so that's probably why the ice is not as thick. It's also warm up here in the Laptev Sea, and then off the coast of Greenland. And as we click around the world, we can see areas that are in the brown zone, which is warmer than we would expect. India is quite brown, and then northern Africa, I'm sorry, that's not India. Sometimes I get mixed up on everything. This is European countries there. I don't always say things exactly the way they should be, so I just do my best. And just click around the globe so you can see what's going on. We can see Antarctica, and then in the southern part it's flipped here, so North Antarctica is over here, South Antarctica is down here. This is the Ross Sea, and it's red down there. And then Australia is brown all the way across the country. We can look at precipitation around the planet and see the green is where it's raining, and the light blue, that's where it's snowing, and the blue areas is where it's snowing. And when you see where it's rain and like the yellow and the red, that's a system, like a hurricane or a cyclone or something like that. We'll just click around the globe. I don't do a lot of weather reporting. There are lots of people who do that, so I kind of like to stick to the sea ice, my observations on that, and bringing you the articles and also bringing you the greenhouse levels from CAMS. That's kind of the areas that I like to focus on, that I feel more comfortable in. So here's our jet stream looping down, and it's quite fast up here coming out of Canada, and quite fast coming over the Pacific Ocean coming into Canada. Oh, I lost my jet stream. And then it loops up into the Arctic, and then it loops back down to Africa, and then does this crazy looping and splitting. And so this is why we're seeing such chaotic weather, and it's because the Arctic is warmer than we expect it to be, and so it's upset the oceans and the air and everything. So our jet stream is crazy everywhere you look. And then you've got your sea ice and snow cover, and we'll just click around. I think it's good to get a different perspective on this and really see how much open water is here coming up from the Atlantic. Now this is Iceland, and there have been so many earthquakes. I was going to pull up my earthquake maps. I don't have them pulled up, but all around the Ring of Fire there have been lots and lots of earthquakes. If you've been watching the earthquakes, and we can see the evidence of the earthquakes when we look at the sulfur dioxide in CAMS. Now here we can see in Antarctica the sea ice is starting to melt. We can see the holes. We can see it not as thick, and it's thinning around the edges as it's melting. And we do expect this sea ice around the continent to melt. It normally does melt almost all totally during their summertime. That's the nature of it. So we're going to be looking at that. And so now I want to show you the sea surface temperature anomaly as well, because this is one of the reasons that the ice is melting so fast in Antarctica, and also why it's not refreezing the way it should be up in the Arctic. It's also causing other problems. We can see red areas even up here in the Atlantic off the coast of the United States and Canada, which is up at like around 5 degrees Celsius warmer than they should be, or normally what we're used to seeing. And then it's red and brown up here in the Arctic, in the Kara and the Barents Sea. And then up here in the Bering Strait and the Beaufort Sea, it's brown and dark brown, and it's even red in the Pacific where it's coming up into the Bering Strait. And it looks like almost all the waters around the planet have quite a bit of brown, meaning they're much warmer than they normally are. And when I was looking at the Pacific, it looks like the whole Pacific Ocean is it's got, look at this whole line of brown coming across, and then it kind of splits out and comes across there, and then there's a huge area up here off the coast of Alaska and Canada, and so these are sea surface temperature anomalies. And then off the coast of southern South America, it's red and brown. There's methane coming off there too. And then around the east coast of Australia is brown and red, so that's quite warm. And then around the Antarctic ice as well. So we're going to leave Climate Reanalyzer now, and my next website I have pulled up is the National Snow and Ice Data Center, and they give a daily news and analysis, and they're a day behind on their images. Here's the sea ice extent in the Arctic like I showed you, and this is the concentration just like I showed you. And here's a graph showing the Arctic sea ice extent, and this is area of ocean with at least 15% sea ice, and the dotted line is from 2012, and that was the year that we were at the lowest ever since they started measuring the sea ice. They started from 1981, and so what we saw is that our extent did not drop below 2012 during the melt season, but now that the melt season is over and it's refreezing, it was below 2012 as far as it wasn't refreezing as the way it should be, well, the way even as much as 2012 was, and now it looks like we're about tied for 2012 on the refreeze, and then these areas are other years. So here's the Antarctic, and you can see the melting ice here, which I'm going to show you that a little bit better in a minute. Let's look at this a little bigger. Here we can see how the sea ice is melting in the Antarctic, and the extent did not come to the point that they were hoping for. So it's melting a lot over here on this east side. So we're going to be looking at that area today. Also, right down here is Pine Island Glacier, and I've got an article I'm going to share with you about the iceberg that broke off a few days ago down there. And of course I did a complete video on the iceberg that broke off last year from Pine Island Glacier, and this is a continuation of continuation of what we were looking at there. And then up here we're going to look at the Larsen C and the big iceberg, the A68, that broke off from the Larsen C last year, and we're going to look at that and see where that is. So we've got quite a bit to cover today, but I still wanted to show you this graph for the Antarctic sea ice extent. It's not good, and it's below last year, and last year it was at its lowest. And of course they're going into their melt season, but it's melting faster than ever. So the oceans are warmer and they come up under the ice and melt it from below. And there are lots of articles about it. I mean, they're getting on board talking about melting from below because the ocean's being warmer. So I'm not going to take a lot of time with presenting articles about that. Okay, here's the Navy website. I have the Antarctic pulled up. Here's our sea ice thickness from today for the Antarctic. And we can see this area over on the east side is pretty much melted, is quite thin. And right along here is the Amory ice shelf. And I showed you that last time. And also down here is the Ross Sea, and there's an ice shelf that comes out there. And the ice has already melted away from that. So we're going to be looking at that as well. And here's the sea surface salinity, and we can see where it's where it's more saline or more salty, it goes up into the yellow and the red and then the brown even, and that's considered salinity for the ocean. And then down, and it's going to be less with the ice that's melting coming off of the glaciers and off of the ice sheets, and you can see that it's affecting the sea surface salinity as well. So now let's hop over to NASA Worldview. I have the Arctic pulled up, and I just wanted to do a comparison while I'm here. And I showed you how to do comparisons last time, so we're going to start the comparison. And what I want to do is 2017. Let's look at the sea ice where it was November 3rd from 2017. And we can see even last year it had come back a lot more than it already has this year. And if I slide this arrow over, here it is this year. And here it is this time last year. And the blue means it's less concentrated. So we can see that where we are this year, it's splotchy with the refreeze, and it's not very concentrated and not very thick. So let's look at 2016. 2016 we had low sea ice as well, and even though the refreeze here on 2016 was not very concentrated, it was already all the way up to the Siberia coast there in the Laptev Sea, which we don't have. It's just not coming back the way we'd hoped it would be. But this is what happens when you have abrupt climate change. I don't know why that's not showing. Okay, here's November 4th from 2015. And look how much better the refreeze was there even in 2015. It's more white, and there's more ice all the way up along the coast there of Russia, and also it's refrozen along Greenland on the north side and the east side and all of Canada and most of Alaska. That was only 3 years ago. Here's 2014. Look at how much better it was freezing even in 2014. It was coming over into the Kara Sea and over by Novaya Zemlya and down by Svalbard. So that's a big difference in 4 years. Look. So that's a huge difference. So let's come back to 2018, and I'm going to stop the comparison, and now I'm going to take off the blue marble layer, and I'm going to take off the sea ice layer. And this is what's visible on the satellite image because the sun is going down up there. And so if we go back, so we really can't see any much of as far as sea ice here. The hole, I call it the hole, where the visible, what we can see, is just really, and soon we won't be able to see anything up here. So let's go back a few days, and if you want to just see a picture of what the sea ice is looking like as it's refreezing, we might be able to see something. It's hard to see with all the clouds. Here's a little bit of ice there, it looks like, but it's hard to see. But we do see green, which is the algae. We do see green there. So since there's not much else to see up there, let's go down to the Antarctic and look at what's going on down here. Here we have our data from today. It's almost all in except for a little part down here. So the first thing I want to show you is let's look at A68 iceberg. Now we have a lot of cloud cover today, but yesterday was a fairly decent shot. Now this is the west side of the Antarctic. This is the West Antarctic Peninsula up here, and this ice along here is what's left. This is what's left of the Larsen A ice shelf. Here's what's left of the Larsen B ice shelf. And this is the Larsen C ice shelf, and then down here, this narrow part is the Larsen D ice shelf. And I did a whole video on the Larsen's ice shelves and how they've been breaking apart down through the years, and so I recommend you go back and watch that, and that'll give you a history of these ice shelves and how they've been melting and breaking up due to abrupt climate change and everything heating up faster and faster and faster down there. Now what we see here, this line is the sea ice where it's come away, and this is the ice shelf down here. And if you see this line, that shows where the ice shelf used to be, but this big iceberg along with sea ice broke off in the summer of 2017 during their winter time, and then it kind of stayed in the same position until this summer, and then this iceberg started moving, and since this summer it's moved, or since April it's moved all the way up. It's going in a counterclockwise direction, and this is where it is today. And we can see that there's a lot of open water around it, and it does move around. This is sea ice over here holding it in, keeping it from drifting out to the ocean. It's huge, and it's called A68. And there are some icebergs over here on the left hand side that there was an article, I forgot to pull it up, but it's about the square iceberg that NASA found, and they took a picture of it, and you know, we were wondering why it was square, and I was trying to look for it, and they said in the article that A68 was looming in the background. And so I was thinking, I've been trying to find a square, something that would look like a square iceberg, and I can only go in that close, and the closest I found was something like right here, and that's not a real good view because we're looking through some clouds, and it's just hard to get stuff because the cloud cover here. I think I'm not going to go back too far. Okay, here's a picture from, actually here's a good picture of A68 from the 21st. Look at that open water. Look at that. Oh, and another thing I learned, see these little streamy things? That's ice, and that's called grease ice. I learned that as well. And when it's streamy like that, and sometimes you'll see it swirling, especially in the Arctic, we were seeing it swirling around. That's from the currents of the ocean moving it around. And so the ice that's on the surface is just a film, but it's called grease ice. I thought that was interesting. And so I'm just looking for that square iceberg, what they might have been referring to, and I can't really tell, or it was rectangular in size, and you know, some people were thinking it might have been photoshopped, but I don't know. I really don't know. I don't have an answer for it. Here on the 30th, we can't really tell. Here on the 31st is probably the best picture, and there's a distinct line going there, and then square down here, and then square angle here and going up. I can't really tell where it ends though, because there's clouds there. So I'm thinking it might have been this iceberg right here, because it is next to this A68, and so if they were taking a picture of it, it could have had this A68 looming in the background. But what's weird is the next day, here's the next day, and it's a better view with fewer clouds, and the edges of it don't even look square. That's the same iceberg, so I don't see how it could have melted that that much in one day, because it looks like a totally different iceberg. Here, I'll go back, you see? And then I go forward, and it looks different to me. What can I say? So here it is from November 1st, and we can see the sea ice is starting to really break apart. I don't know if A68 is going to make it out into the ocean before their summer is up or not. We'll be watching that though. So there's that. And now we're going to hop over to the Amory ice sheet over here. This is where we saw it, the big hole in the ice on the Navy website. We can see that this ice is pretty much melted. It's just very thin. And this is an ice sheet that comes down. There's a big glacier up here, and so we'll be watching this to see what comes on down into the ocean, because with the water so warm it'll be coming up underneath and melting that. Then we have that. Remember, I did an article about the Totten Glacier ice shelf. That's right here. That's cloud covered today. But if we go back a few days, you can see that there's still ice there. So, but this is open ocean here. And here's some of that. This is ice. This is that grease ice I was telling you about. Now, okay, here is the Ross Sea and the Ross ice shelf. Here it is from today, and we can that we're looking through clouds, and we can see that it's melted all the way around the ice shelf. So that's going to be probably melting pretty fast up underneath there. And then over here is the Pine Island Glacier area right here. It comes down through this way, and then there's a little ear, and this is what we're looking at for the break off. And I've been upset because it's been cloud covered. I did find one day in the morning where it was not cloud covered, and I did not take a screenshot of it, and then I went back a few hours later and it was cloud covered. So I guess their data that came in covered it up. Now here it is from today, November 3rd. I need a drink of water. Now we're not going to be able to see much from NASA Worldview, but here's the article. This is from Mashable. This came out, I think, like 4 days ago. And so I'll just read you a little of the article. A giant Antarctic iceberg snaps into the ocean after forming ominous crack. Well, first of all, it's not in the ocean yet. It's still held in by sea ice. They make it sound like it's just going to be floating around. And so I don't know where they got their pictures from, but according to NASA Worldview, it's not floating out into the ocean yet. So, anyway, and it did break off a big iceberg last year, but that already broke up into pieces. Okay, this says Okay, 4 days ago, by Mark Kaufman. After a nearly 20-mile rift formed across Antarctic's retreating Pine Island Glacier in late September, about 115 square miles of ice, an area more than 5 times the size of Manhattan, has now broken off into the sea. The single largest chunk of ice is 4 times the size of Manhattan. This iceberg calving event reinforces a continuing story of the melting and retreat of Antarctic glaciers, particularly due to relatively warm oceans eating away at the ice from below. And this is a video, and it goes from September the 28th through October 28th. I'm going to try and stop it, or through the 29th. Here it is on the 29th. Now this is, I'm not from NASA Worldview, and I don't have access to whatever this guy has. So here it is where it's cracked off, and then but it's not going out yet. There's sea ice holding it in. And these icebergs here, those are the remnants of what broke off last year. So that's what broke off. And then here's a picture of what happens. And the grounding line keeps moving back because the warmer water keeps moving in and it's melting the ice from below. So, and the icebergs disintegrate more rapidly, and those do add to rise in sea level. So here's from NASA Worldview what we can actually see. Here it is from today, and let's see. Okay, most of this is cloud cover. Where you see colors is sea ice, where it's not cloud covered. So we can see that we're looking through clouds here. Actually, there is open water down here, but this is sea ice here. We can see the edge of the sea ice coming up, and this is the Pine Island Glacier, and all we can see today is a little line here representing a crack on the bottom part, and a little line here representing a crack on the top part. So it's disappointing. I know. I've been looking at this every day, and it's been cloud covered. And here it is on November the 1st, where the clouds lifted a little bit, and here's that crack going and it does go all the way across, and then on the bottom part. And here it is on October 31st, and the 30th, and the 29th was the best view. But we're looking through a lot of clouds, but you can see, and that's as close as I can get in, you can see the crack starting here, and it goes all the way up, and then the crack at the bottom. And so this has broken off, but it's not floating out into the ocean yet because there is sea ice. And if you want to, what we can do is let's go back to November 3rd, today, and if you want to see oh wow, all of a sudden it's showing something. I haven't even put the comparison up yet. Let's see what happens. 2017. Oh, I guess the comparison is backwards. Let's see. No, it's okay. Here it is in November 3rd from 2016, and we can see all this ice has melted, and it was a really good day to see this because there were not a lot of clouds. Now, 2017 though, we can't see a lot. That was cloud covered there. But I did a whole video on that breaking off, and here's the line where it broke off last year. You can see it there, kind of through the clouds. There's a good picture of where it broke off last year. Okay? And it almost looks like it's kind of going up into the same area. But this comparison I don't think is working very well. So let's stop the comparison. So there's November 1st, 2017. So try to remember that. And now 2018. So it looks to me like the crack is up a little higher. So it's just more of this Pine Island Glacier, and they're worried because the more this glacier breaks off, this acts like a cap, then the glacier is going to be flowing faster, and more of this ice sheet is going to be coming down into the ocean. So we're going to leave NASA Worldview, and I'm sorry I wasn't able to get a better view than that for you, but now here's yesterday where we had fewer clouds, so we can see where the edge of the sea ice is. So it is melting, but we expect it to melt, and so this is ice here, this is ocean here, and so that big iceberg is not floating out into the ocean quite yet. We can see here's a day where it was relatively cloud-free down here. This is still sea ice, and it's hasn't started floating out into the ocean yet. So you don't have to be afraid of that big iceberg going anywhere at this moment. So I'm going to leave that. I have one more article to share. This is from the Barents Observer. And it's from October the 9th. Melting glaciers at Novaya Zemlya contain radiation from nuclear bomb tests. So I think someone must have watched my Novaya Zemlya video and got some ideas. A science expedition to the area has discovered big concentrations of radioactivity in the ice and concludes that the glaciers are melting into the sea at record speed. By Thomas Nilsson. So they talk about the radiation and from all the nuclear testing. I went over all of that in my Novaya Zemlya video. So and my theory was that the Arctic is warming up so much faster and started warming up so much faster because of the radioactive fallout and the junk that was dumped into the ocean there, and that it was hot and, you know, causing the ice to start melting faster. And that radiation is, you know, it's not going anywhere. It's going to stay there. And now these scientists have decided, oh yeah, the primary goals for the Russian researchers were to study whether hundreds of containers with dumped radioactive waste in the Kara Sea were leaking or not. Well, that's a scary thought. Sailing the Kara Sea and the bays along the east coast of Novaya Zemlya from August 17th to September 20th, the researchers on board Academic Keldysh conclude there are good reasons to continue monitoring the dumped containers, but preliminary results give no indications of leakages. Well, good luck with that. However, especially one barge that was discovered at 400 meters depth, filled with radioactive waste containers, requires special attention for the future. Underwater footages show the barge is destroyed and some containers have fallen out and are spread on the sea floor. More worrying is the radiation discovered in the glaciers stretching out in the waters. From 1957 to 1962, a total of 86 nuclear bomb tests were carried out in the atmosphere at Novaya Zemlya. The tests include the largest nuclear devices ever exploded, like the so-called 58 megatons Tsar Bomba on October 30th, 1961. Well, we just had that anniversary. Most bombs were exploded above ground at the northern polygon near the Matochkin Shar, dividing the northern and southern island of the archipelago. Wind direction for the most was towards the north when the test took place. It is the fallout from these tests that are now about to melt to the sea. So they're going to test those glaciers for radioactivity. On Novaya Zemlya, the wind direction is such that most of the pollution is accumulated on the northern island and the northern ice sheet. We've studied one of the glaciers that could carry such pollution, the Nally Glacier. And in this glacier we found parts that hold big concentrations of radioactivity, Mikhail Flint says. I would not give any exact estimation about the discovery, but in these parts of the moving glacier there were found doses that twice exceeded that baseline level on Novaya Zemlya. Explaining how the glaciers in the area are retreating, the researchers tell how Academic Keldysh sailed to the point in, I can't say that, Blagopaluchi Bay, where the Vershinsky Glacier in 2014 ended in the sea. Today, that spot was more than 2 kilometers out from where the terminus of the glacier is now. The majority of the northern island on Novaya Zemlya is covered by ice and glaciers and have their terminus on both the eastern and western shores. That means both to the Barents and Kara Seas. While there are close to nothing of commercial fisheries in the Kara Sea, the Barents Sea has a high biological production, and the fisheries, in particular the cod fisheries, are of great importance for Norway and Russia. And I read one article that said the Kara Sea is the most radioactive sea in the world. So there's that. So we're going to leave all of that. I'm going to close that browser down. And now we're going to go over to CAMS. This is Copernicus Atmosphere Monitoring Services out of the EU. And I'm going to start with methane. We have data. Our latest data is from Thursday, November the 1st. I already have it loaded up, and we're looking down from the North Pole. So let's let this movie run. Might be a little jumpy the first time through. We can get a pretty good view of the whole northern hemisphere in this shot here. The greens, the highest green, like the chartreuse green, is about 1900 parts per billion, and then once it starts going into the yellow, it's 1920, and it's going higher. And the gold is 1960. The red orange is 1980. The bright red is 2000 parts per billion. The brick red is 2040 parts per billion. And the black is 75,600 parts per billion. Now, I'm just going to let this movie run while I talk. We have data from Thursday, and then it goes into the forecast period. This is a computer model that's put together from data that they get from different data sources around the world. And what we see here is methane. We're really particularly looking at methane, in Siberia from the permafrost coming up. It's also coming up wherever it's wet or humid or a high industrial civilization. So, but when it's coming up out of the ocean, that's really cause for concern, and we do see it coming up out of the Arctic Ocean. We're coming up here north of Norway and up through Novaya Zemlya, and here right near the North Pole, it's coming up out of the ocean as well. And we see higher levels streaming around, but it is less than it was during the summer because it's getting cooler. But we are seeing over here in North America pretty high levels over from the mid-United States all the way across east, and pretty high levels in Canada, but they're going down since it's cooling down there, and quite high levels in California and down here going into Mexico on the Baja Peninsula. And then another area that I wanted to show you is over here, China and this Eastern Asia is like covered up in this black, and then India, and look at how it's just the whole ocean here, this Indian Ocean, and then over here to the west of India is like it's coming up out of the ocean too. I don't know if it's just flowing. This is surface level, so I think it's coming up out of the ocean too. So I think that's how polluted everything is. These are quite high levels. So I'm going to stop that. Next I have sulfur dioxide loaded up for you. And I have the Pacific view. So if you'll orient yourself, here's the North America. Here's Alaska up here. Here's Hawaii. Here's South America. Here's Mexico. Here's Russia and China and Australia down here. So I already have this movie ready to go. And our data, the day I started with was Wednesday the 31st, because what we're seeing is, and then it goes into a forecast period after a few days. It'll smooth out once it runs through the movie once. But where you see like where it's gold, but also really the red areas, that's usually a sign of geologic activity, like a volcano explosion. Like we can see Hawaii is still red coming off of there, and we have Mexico. We still have an ongoing eruption down in Mexico, and then down here in the Solomon Islands with Vanuatu and Fiji and these areas, there was a lot of activity with earthquakes all around the Ring of Fire this week, and a lot of volcanic activity down here, and you can see evidence of it, and where it just popped up that red, and then it spreads out and goes across the Pacific Ocean. And also of concern is this red coming up off the land. This is China here, and then this red moves around, and it's the Beijing area. I don't know if, I guess all of that red, the sulfur dioxide, is from pollution. I guess. I don't know if they have any volcanic activity going on. I know they've had some earthquakes over in China this week, but usually when you see the red like plume up, a lot of times it'll be before earthquakes happen, but it's usually a sign of earthquake activity. Or if it's on land and there are no earthquakes, it can be from high levels of pollution. Next, I have ozone pulled up. I have the South Pole view here, so if you'll orient yourself, here's South America and the south tip of South America coming down, and this is the Antarctic. Here's the east side and here's the west side. And I chose the base time for today so that we can see where we are at right now with the ozone levels. And this is surface level ozone, not surface, I'm sorry, this is total column ozone, which is the good ozone that we want, that protects us. Our base time is from Saturday the 3rd, and now we can see that these levels are quite low still in the Antarctic. It's the hole is kind of morphing, and you can see where it goes into the forecast period. The hole even comes up and touches the tip of South America there. But it's still covering most of the continent, and on the total column ozone, we want it high. We want it as high as we can get it, because that's what protects us from the UV rays. And the ozone layer is thinning around the planet, and I'm going to show you something quite disturbing in a minute. And so what we're seeing here is when you get into like this chartreuse, that level, that reading is 260 DU. That means Dobson units. And that's how ozone is measured. And when you get down to the aqua, that's 220 Dobson units. So we have a little bit of aqua here. Then this black line is the demarcation between the aqua and the blue, the light blue purple, which is 200 Dobson units, and that denotes quite thin. And then it goes down from there. It goes down into 175 is this blue, and then 150 is this brighter blue, and then the navy blue is 125. And I'm not seeing any black here today in the center, which is good. I was seeing black for a little while, but the ozone hole should be starting to close back up now that the sun is up in the Arctic, and it should be creating ozone, and we should be losing these high or these readings of such low ozone with it being so thin. They should be getting higher. So that's what we're going to be looking for as the weeks go by. So now I have ozone for the global view pulled up for today, and this is total column again, and we'll let this movie run through. We can see the North America over here. Here's Greenland, here's South America, here's Africa, here's Europe, and the Norwegian countries, and then Russia goes all the way across, and then China and Asia, and then down here is Australia, and then New Zealand is down here. Hawaii is over here. So as this is running, first of all, we have a thin level around the middle part of the continent, or of the globe, is thin. And you see this? I haven't seen that before. That has popped up. That's the first time this is my first year to be studying and watching these greenhouse gases. So see, the aqua starts over Norway and then moves over, and then it pops up into the blue, which is 200 Dobson units, and makes like a hole over Russia, and then it kind of closes back up. Now that's in the forecast period. Here, see that pop up? That's not good. So that's quite thin all the way over Russia. So there, or this area before it goes into the Siberia part. But you know, UV radiation is going to be coming through like mad over there. And it's thin wherever you see the green or the blue-green, it's thin. And so, and there are areas of the ozone where it's thicker than it was, which is good, but it's just like in clumps here and there. It's not uniform. And I know that the sulfur dioxide does break down the ozone layer along with a whole bunch of other stuff. So that's my show for today. That's my report for today. I hope this helped you in understanding where we are. Time is short. We are in the end times. I do believe it. And I recommend everyone get their spiritual houses in order, because I don't believe we have much time left. And as I'm looking at the Antarctic, it's you can see it does go into the black a little bit down here. I'm thinking it does. It's hard to tell. But anyway, everything is dire. Things are ramping up. People can feel it. You can feel the chaos, and you can see it in the politics and in the news and the economy and the weather and the flooding and the earthquakes and the volcanoes and the evil that's manifesting. And time is so short. So I recommend everyone get your spiritual houses in order. I love you. And until next time, go in peace. God bless. And goodbye.